All right, so refresher on, well, before we leave it, 19, so your cosine stuff. So as far as, or sine stuff, so as far as unit circle goes, I would say what I would want to do to be prepared is know all the, like, each of one angle. So, like, obviously, I need to know the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi, and your coordinate points there, which would be 1, 0, 0, 1. Negative 1, 0, and 0, negative 1. And then I would want to know every over 6, every over 4, every over 3. So we know an over 6 has the coordinate point root 3 over 2 and 1/2. And the tan, so this is my cosine and this is my sine. And the tan, which would be root 3 over 3. Every over 4 has the coordinate point root 2 over 2 and root 2 over 2. And the tangent is 1. And every over 3 has the coordinate point 1/2, root 3 over 2. And the tangent is root 3. And then all students take calculus. Is going to help you with your positive negative signs. The other thing I would make sure I knew is your inverse restrictions. So remember, if it's a sine -1 or a tan -1, we use the fourth quadrant but the negative angles. So we use the negative angles. And we use the first quadrant. And then in my numerator, I mean in the top is cosine. And cosine we use the natural angles. So those are ones that, like, when you, like, let's say it was open-ended on a test and you gave 2 answers and one was wrong, maybe you got partial credit. Whereas now you give one that's wrong, you're getting no credit. So you would lose the points entirely for that stuff. I think we did 18 yesterday. That's where we stopped. Okay, 18, which of the following polar coordinates is not equal to the rectangular coordinates -1, 3? So this, we're going from rectangular to polar. So to get the r, we do the square root of x squared plus y squared. And to get theta, we do tan -1 of y over x. So the r was, well, it would be 2 if you look at all the values, it's 2, but the square root of -1 squared plus root 3 squared, which is the square root of 1 plus 3, which is square root of 4, which is 2. And then your tan -1 y over x would have been root 3 over -1. So piggybacking on what we just did, this is saying that the tangent is negative root 3, right? So when you go to your unit circle, there are 2 answers for tan being -3. It would happen in your second quadrant and your fourth quadrant at the over 3's there. So it would be 2 pi over 3 or 5 pi over 3. But there's only one right answer for this. In order to figure it out, you got to figure out where your original angle lives, or your original coordinate point. So if my coordinate point is a negative x and a positive y, what quadrant is that in? It's in the second quadrant, which means I would pick 2 pi over 3. So the first representation of this coordinate point is 2 comma 2 pi over 3. So if I looked at my answer choices, that was 1, I would cross it out. But it didn't say which one was it. It said which one wasn't it. So the other way, if you remember how we find our additional representations of a polar coordinate, you have 2 choices. You keep the r, and you add and subtract even multiples of pi, or 2 pi to start with. But you could also add 4 pi, 6 pi, and so on. Or you change the sign on the r, and you add and subtract odd multiples of pi, and we start with pi. So if I look at the answer choices, if I keep r, so like if r was positive 2 and I go to C, this should be 2 pi over 3 plus 2 pi. Or 2 pi over 3 plus 6 pi over 3, which is 8 pi over 3. Well, that's a 3. Sorry, 8 pi over 3. 5 pi over 3 is adding pi, and you can't keep the r and add an odd multiple of pi, so that doesn't work. The other way to do it is plot your initial point. So like if I plot 2 pi over 3, 2, I'm in my second quadrant. So you can also go through these and see which one is in your second quadrant. Like that's another way to do it. And there's a question on one of the tests somewhere that simply says which of the following is in the second quadrant. So I would say make sure you'd be able to plot each of them instead of having to find them. So if I did negative pi over 3, negative 2, negative pi over 3 is in my fourth quadrant, but negative 2 goes to that point. So that one would be the same as the original. If I did 5 pi over 3, 2. 5 pi over 3 is in the fourth quadrant. Positive 2 would be towards it. That one's in the fourth quadrant, so I know it's wrong. The last one is negative 7 pi over 3 and negative 2. So negative 7 pi over 3 is the same thing as negative 2 and 1/3. Negative 2 would be all the way around my unit circle. 1/3 past it would be in the fourth quadrant. Negative 2 says go away from it, so that also lines up with my original one. So for polar and rectangular, you got to know how to convert from one to the other, and you got to know how to find each additional ones, or draw them out. I mean, plot them.
Wait, what did you say about like the negative or something?
The negative goes the other direction. So like if I had, let's say I had negative 3 pi over 2, for example, right? Pi over 2 is at the top, and if it was a positive r, I'd put it up here. But because it's a negative, I go the other direction. I'd go 1, 2, 3 down, and that would be my coordinate point. So the negative r tells you go away from the angle on the opposite ray.
Wait, what about like the odd thing though?
So if you have any polar coordinate and you want to find additional representations of the same one, then the one way to do it is you keep the r and you add and subtract even multiples of pi because you want to go all the way around your circle, right? Or you change the r so it would be halfway across your circle and you add and subtract pi. The sign on the r. So if it's positive, you change it to negative. If it's negative, you change it to positive. Yeah. Yeah, they give you like, I think 3 scrap pieces of paper per kid. Yeah.
Then I subtract pi.
Odd multiples of pi, right? So you can add pi, you can add 3 pi, you can add 5 pi, that like that. All right. 19 is one of those gimme questions. Like if you know your unit circle, you know your over 6s, you would know that coordinate point is root 3 over 2 and 1/2. You're in the third quadrant, so your sign is negative. You grab the negative 1/2. That's it. You're done. Move on. Got yourself some easy points. There will be questions like those, so use those to your advantage. All right, number 20 said, consider the function f given by log base 4 of x squared minus 4 minus log base 4 of x squared plus 2x minus 15. Of the following, what are all the coordinates of the x-intercepts of the graph of f in the plane? So remember, if it's a minus and we're condensing it, it becomes division. So this would become log 4 x squared minus 4 over x squared plus 2x minus 15. And then I would go as far as making sure that this doesn't cancel. So x minus 2 over x plus 5 and x minus 3. Make sure nothing simplifies there because that would cancel out one of your intercepts. Nothing does, so we keep it. Now, how do I find an x-intercept of a graph? Is the x the 0, the y the 0 if it's an x-intercept? The y is a 0. So if this equals f of x, I'm going to set it equal to 0. So 0 equals log base 4 of that whole thing. X plus 2, x minus 2 over x plus 5 and x minus 3. How do I solve if there's a single log? Good. Convert it to exponential. So 4 to the 0 would equal that whole thing again. X plus 2, x minus 2, x plus 5, and x minus 3. And 4 to the 0 is 1. Okay. Now, what? So I can multiply, and I get x plus 5 and x minus 3 equals x plus 2 and x minus 2. I'm actually going to go back and distribute that out because I'm going to have to combine like terms anyway. So this was, if I go back to like what the original question said up here, x plus 2x minus 15 equals x squared minus 4. Now when I subtract, the x squareds cancel out. I get 2x minus 15 equals negative 4. Add the 15. 2x equals 11, and x equals 11 over 2. That's the x-intercept, which is D. Remember, you have to check your logs, though. Like, make sure, because that comes up, like that showed up on a practice test or a test somewhere, whatever, too. Like, you get 2 answers. You have to make sure that the logs can use those answers. So you got to go back and check at the beginning. If I plug in 11 over 2, will I be able to find the log of what's next to it? So you want to make sure, like I would say in this case, I would look at my answer choices and no solution is not there. So I wouldn't worry about it. But if there was 2 answers there and one of my answers eliminated one of them, I would certainly look back and make sure that those questions, like remember when you plug them back in here, you have to see if it would give you a negative or a 0. If it does, you can't keep that answer. Does that make sense? You have to check your logs. Yeah.
What's the rule? Oh, just logs? Like it's not.
Just logs, which would be logs or ln, but just logs. Yeah.
Can you zoom into like the word?
Yeah. Is that good? What do you need? All right. 21 was your polar one. So we definitely got to talk about these. Okay. Our polar equations or polar functions. These were your limicons, your roses, your circles were in here, okay? Most of what I've seen on any of the practice tests, though, come between these two. So the roses or the limicons. You've got to understand the graphs of them. You could plug in points a lot of times, but you got to understand the graphs of them and the rate of change. So remember, this is where it was like, what's true about the distance between the graph and the pole, and you had to figure out was R positive and increasing or was R negative and increasing or decreasing, that kind of stuff. I've seen one question of each of these on every test, so you're going to get a polar function, okay? So the limicons are the ones that would be an f of x equals, no, sorry, an f of, I think it's an r of theta. R of theta equals, and it's a plus or minus b sine theta or cosine theta. And these were your inner loop, your cardioid, your dimpled, your convex. And we start with A over B being less than 1, then being equal to 1, then being in between 1 and 2, and then being greater than 2. Is that how it was?
Greater than or equal to.
Thank you. That one's the equal to, right? And that one's the 1. Yes. And this is your inner loop. And this is your heart-shaped or your cardioid. And this is your convex. Nope. This is dimpled. And this is convex. If it's a sine, then it had access to the, symmetry to the pi over 2. So your loop or your whatever would be at the top or the bottom. If it's cosine, then it had symmetry to the polar axis. So your inner loop would be or on the left or the right. And then remember our max point was A plus B, and our min was A minus B. I think if you know those things, you should be able to identify it if it was a multiple choice. I feel like just that should be enough between your symmetry, knowing if it's an inner loop or a cardioid, like those, and then your A plus B. I feel like that, everything I've seen, that has been enough. You don't have to then plot points. You could always plot points if you didn't know, but for everything that we've seen, that was enough, okay? The other thing you could have to do, which I'll get to in a second, is figure out your rate of change. Like, is it increasing or decreasing? Yeah.
Is there a greater chance of it being on the F bar here or just multiple choice?
I feel like these are only going to be on your multiple choice.
So we wouldn't have to like graph and then
No, there's no graphing questions. Like, and not in any of the practice. Like a physical hand graph. There's none. None. I mean, I'd be surprised if it showed up because it's not on any practice. Yeah. Okay, then your roses were your R of theta equals, and it's a number. I can't remember what variable we used. I think we used A, right? A sine n theta or A cosine n theta. This time there was something being multiplied by your theta. If n is odd, then there are n number of petals. N would be a number here. So if let's say that's at 3, then there'd be 3 petals. If n is even, then 2n number of petals. You double it. Do we remember this? Yeah. The same symmetry rules apply. If it's cosine, it's polar axis. If it's sine, it's pi over 2. And we added if n is even, then it has symmetry to the pole. The pole is the origin. So like if it was even, it would have to, whatever was happening in one quadrant was happening across from it like that. It could also be like this. So for these, the easiest way was to find the pedal, right? Find your pedal by setting equation equal to R. Well, to A in this case, which was your radius. So A is your pedal length.
Setting it equal to R.
Setting it equal to A. So A, I mean, you could do both. A is your R. A is your radius. A is your pedal length. If you set it equal to it, it will help you find where one of the pedals are. So if this was multiple choice, and let's say it said a 2 theta, so you know it had 4 pedals, and one was this and one was this, and you had to figure out which one it was. You could choose to either plug in a point on the like I could plug in 0 and see if there's a pedal there, or in this case plug in pi over 4 and see if there's a pedal there. That's one option. The other option is to set it equal to the pedal length, and it will tell you which angle has that pedal there. Hadley.
Which one's even, which one's odd? The one on the right.
Those are both even. These would both be 2 theta.
What was it like?
An odd would be, so an odd, like let's say it had 3, would be like that.
Oh,
Yeah, or 5, it could have 5. So the example here, right, so this 121 says the graph of 3 cosine 4 theta shows as follows on the xy plane. As theta increases from 0 to pi, which labeled point would be traced first? So in this case, so I've seen multiple choice questions with these where it'll give you 4 and you have to choose which one it is. Obviously, I think what we just did was enough. But then I've seen 2 kinds of questions like this. One where you have to figure out what order would that have been plotted. You would plug in. So I would plug in 0. I would plug in something between 0 and 2 pi. Like literally I just kept plugging in points until I figured out the pattern. So when I plugged in 0, I got 3, 0, and that told me that this point was first. The one on the right. Then I plugged in something, I think I plugged in pi over 6. Pi over 6 gave me pi over 6 and negative 3 pi over 2. And that was this one over here. So I went from here to here. Like you went that order is what you would need to know. And then I plugged in pi over 4. And then I plugged in pi over 3. And then I plugged in pi over 2. Pi over 4 gave me this coordinate point. So now I know I'm going in this direction. Pi over 3 gave me this coordinate point. So I'm continuing in this direction. And then I didn't know if it went here and back or if it went to the top. And that's how I plugged in pi over 2. And I got pi over 2. 3 pi over 2 was the last point. So I know I went up here.
Wait, where do you plug it into?
The equation.
Yeah, I know where.
Oh, into theta. So when you're plugging into the angle. So like if I plug in 3 cosine 4 times 0 would have been the first one. I would have started where they told me to start. And I would have gotten 3 cosine of 0. The cosine of 0 is 1, and I got 3. So that told me this was my first point, the point there on the right. But that wasn't one of my options on the bottom, so I kept going.
Cosine of 0 is pi.
Cosine of 0 is 0. No, cosine of 0 is 1. Because on the right. Yeah. So you're for sure going to end up plugging in some points, either to get a question like this to figure out the order, or to get a question like what's happening with R. Is it increasing or decreasing? The distance from your pole to R. Yeah.
Do you plug in negative or no?
You get to plug in whatever you want to plug in. For me, I did these points here because that's where it was talking the range. So I would have started at the smallest one because it wanted to know which one would be hit first. So I started at 0 and I worked my way up until I found one of the points. And the first one I hit was C. So that was the first one that would have been plotted. Does that make sense? Okay. Yeah.
Can we not practice on these?
So this is what I said the other day. I only have one more of these practice tests for the 5 steps. I'm saving it till the end of next week. Monday and Tuesday, we're doing another secure exam. So that will be more practice. And then I'll post this again. But then that's it. Like those 2 are the only ones
Make extra practice on
specifically polar. Sure. Yeah. Yeah. And note that these are not calculator questions. So this is what's going to show up on your first test from me. This is what's going to, like, this could be your bank of questions. Okay?
Can you graph them? I was on your graph calculator.
Sure. But you won't have your calculator.
Oh, I thought we did on this part.
No, we still haven't hit the part. This is right. 1 through 28 is no calculator. All right. 22 said consider the function. Now we're back to our end behavior. Which of the following is true about this is if it was approaching 3, that would be if it was a whole. Approaching 4, there would have to be a whole or an asymptote. Approaching infinity or negative infinity. So what I did was figure out from my initial equation what this graph might look like. If you factor out the bottom, nothing canceled. So then I was looking for my asymptotes. There was an asymptote at x equals positive 4. And there was an asymptote at negative 3. Then I had to figure out what was happening in between there. Is my graph going up to the right or down to the left? In which direction is it going? Okay. And if you look, these are end behavior. C and D were end behavior. So I determine end behavior on my horizontal asymptote. Remember yesterday we talked about the degree in the top and the bottom determines your horizontal asymptote. If it's bigger in the top, then your horizontal asymptote is at 0, which means to the right and the left, in both directions, I'd be approaching 0. So then I looked to see if that was one of my options. As it approaches positive infinity, it was 1/2. That's wrong. It should have been 0. As it approaches negative infinity, it's 0. That's right. If that one was not there, I would then have to figure out what's happening as I get close to 3 from the right. So from this side, sorry. Close to 3 from the right. There's no asymptote here. So something's wrong with that. And as I go to 4 from the left, now I would be trying to figure out, is my graph going up or down? And for that, I'd have to figure out what's happening in between there. I'd look for zeros and I'd look for I'd plot some points if I didn't know it. Questions on the end behavior? We talked about it yesterday, but it's going to for sure show up. Okay, 23 said the mean monthly high temperature throughout the year for a city periodically increases and decreases. The average time between consecutive maximum mean monthly to high temperatures in the city is 12 months. So max to max is 12 months, and that tells you what? Period. The period. So from max to max, or from min to min, would equal the period. If it gave you from max to min or min to max, that's half your period. So you have to pay attention to that stuff, okay? When's it hit the high? If it hits the high again, that's your period. If it's low to low, that's your period. But if it's high to low or low to high, that's half your period. You'd have to double it. So that's the first piece of information I got from this. If you looked ahead at your answers, though, they were talking about A. And A comes from what? How do you determine what A is? The amplitude. And what values determine your amplitude? The X's or the Y's? The Y's. So you're looking at the value of your max to your min. Remember, A is max minus min divided by 2. This is your amplitude. And D, if it had asked for that, or your midline, right? That's max plus min divided by 2. So it gave you the period information, but you didn't really even need to know it until you got to the rest of it. The average change in mean monthly high temperatures in the city between maximum mean monthly high temperature and the minimum mean monthly high temperature is 26.1 Fahrenheit. So that is your max minus your min. So if I want to find A, I literally just divide it by 2. So we also needed to know period, right? Period is 2 pi over b, and if it gives you b, if it gives you the period, b equals 2 pi over the period. So those are the things you have to know from sinusoidal, basically, and then your phase shift. But your max minus your min, or your max, or your min to your min is your period. Your max, your min, or your min to your max is half your period. Your max minus your min over 2 is the amp. Your max plus your min over 2 is the midline. Period is 2 pi over b, and b equals 2 pi over period. Those should answer most of the word problems on your sinusoidal stuff. All right, 24, the following graph is a sinusoidal function, and it gives you the equation where a, b, c, and d are constants. Which of the following represents the correct value of the constants? So I have my max at 5, my min at 1, which means if I was looking at amplitude, or a, it'd be 5 minus 1 divided by 2, which would be 2. A equals 2 is not an option, okay? A does not equal 7. If I wanted d, d would be 5 plus 1 divided by 2, or 6 divided by 2 is 3, and that one was there. B would have been 2 pi over the period if I looked at the period, and you could look at it from here to here, which was from -5 to 3, so the period is 8. So 2 pi over b would equal 8, or 2 pi over 8 would have equaled b, and b would be pi over 4. So that one was wrong. And then if it's a shift, this said cosine. So if I started it here, my shift was left 1, so my C is a positive 1. That one was the closest to being a distractor, so be careful. Remember, if we're going left, then it's a positive 1 for C. So D was the only one that was right. All right, 25, a concert scheduled to begin at 8 p.m. The doors to the concert hall open at 5 p.m. Let T be the minutes after the concert hall opens. The number of people inside the concert hall at 5:30 was 24. So 5:30, which would be 30 minutes after the start, was 24. That's a coordinate point, or A30 equals 24. You could look at it either way. And then there were 48 people in the concert at 6 p.m. So 1 hour or 60 minutes after, there's 48 people. So A60 could have also been 48. The number of people in the concert hall is increasing exponentially. Which of the following models? N, the number of people in the concert hall as a function of T, the number of minutes after 5 p.m. So this doubled. 24 went to 48, which means it doubled. We talked about doubling time, right? It's initial, so double.
It's called double life.
Double life, yep. Initial times 2 raised to the time divided by n, where n equals the time it takes to double. So initial was, if I had to go backwards, because I started at 30 minutes, it was 24. That means 30 minutes before, because it took 30 minutes to double, it'd be half of 24. So my initial was 12, 2, T over how many minutes does it take to double, and that's 30, which was B. That's it. That doesn't even look like an IN, but that's what that is. Initial time. Initial amount. And is the time it takes to double. It would be the same if it was half-life, except it'd be a half, right? So it'd be the initial times a half, T over N, where N is the time it takes to cut in half. So they're the same. It's the only thing it changes is 2 and 1/2. Yeah.
Now the initial is 12 because at 30 it's 24.
Correct. And it took 30 minutes to double, so you work your way backwards. Yeah, you could plug it into the formula, but I also think it'd just be easier this one you only had to go back 1. But you could have plugged it into this kind of thing. Like once you figure out your doubling rate, you could have plugged it into a geometric sequence too. All right, 26 says, which of the following is not equivalent to log base 4 of 10? So this is your change of base. Change of base on logs, okay? If it said log base A of B, then this is the same thing as log of B over log of A. This could also be ln of B over ln of A. It could be any base. So if you looked at log base 4 of 10, it says which one was not equivalent to it. And if log base 4 of 10 log base 10 over log base 4 was an option. That's the same thing. I would have canceled that out. This is also the same thing as saying 1 over log base 4. So that one ruled out A. Log base 2, 10 to the square root would be 1/2. 1/2 log base 2 of 10 would also be the same thing. And then log base, so the only one that changed the base that didn't work was C. So if I did log 16, it would be log of 100 over log 16. Log of 100 is 2 over log 16. Which would be equivalent to like raising these to the power. So those are the same. This one you have to go through your change of base. You have to understand the logs. Like you have to understand if I raise it to a power, it raises both to the power. If I square rooted both the 10 and the 4, I got this, which was one of the answers. So the only one that didn't work was C.
I don't really get that.
I don't get A.
A is, so if you rewrite it as your log base, so log base 4 of 10 can also be written as log of 10 over log of 4, right? That's your change of base. And log of 10 is 1.
Oh.
So 1 over log of 4 was one of your options. That's the same. That's an equivalent. All right, 27 we kind of talked about yesterday. What would happen if you had taken something that was multiplied by 3? The B is pi. The C is, oh, this one I would say. What's tricky here is that you have to take out the pi in order to find C. So pi comes out, and I'd get x minus, this would be pi over 2 divided by pi, or pi over 2 times 1 over pi, and that's 1/2. So the format on this was tricky because we talked about it, what happens if it's not separated. But a lot of what they do separates out your B. That's your B. This is your C. This is your vertical stretch, your vertical shift, and this is your vertical stretch. So if it says the x coordinate is affected by the stuff inside the parentheses. It's affected by your shift to the right, pi 1/2, and your factor of pi, which would be a horizontal dilation. Factor of 1 over pi, and a horizontal shift. Right, 1/2. So the coordinate point, pi over 4, 1, you're looking at the x. So I took pi over 4. I multiplied it times 1 over pi because you do your stretch first. I got 1/4. And then I added 1/2. And that's 1/4 plus 2/4, which is 3/4. All right. Because it said the x coordinate. Yep, if it said the y, I would have worried about my vertical stretch and shift up or down. All right, last one on this one was your slant asymptote. So how do we find a slant asymptote? Long division, especially this time because the bottom has a squared in it. So you had to divide with long division. And again, I think that that's an easy question if you know what you're doing, right? There's no trick to that. Just divide and ignore your remainder. And you should have gotten y equals x minus 4.
That's the one you have to put instead of x squared plus 4, you do x squared plus 0x.
Yeah, you have to, anything that's missing a term, you've got to plug in. Yep. Here's what you have to be careful on. This is the graphing calculator portion, but something like 77, you did not need a graphing calculator, right? So you have to be careful of this one, 79, didn't need a graphing calculator, okay? Those things you have to also make sure you're reviewing. So 77 was your sum and difference formulas. 79 was reading your chart, finding f negative 1. Set 80 did not need a calculator. Um, 83 did not need a calculator. $85 did not need a calculator. Oh, okay, go to 87 real fast. This I don't think was on our cheat sheet, and it came up on this test. Remember, R is the residual, and R is the distance between what the actual and the predicted. The sign on this even came up, so be really, really careful. 87, when you're talking about the residual, the order is actual minus predicted. So think A comes first. Actual minus predicted. Because that, in this example, gave you a negative. If you didn't know that, they all had the same value. You had to know which one was the right sign. So actual minus predicted, and that will be on the calculator portion, but that was not on our little cheat sheet. Okay? And then you, from there, would know if it's an overestimate or an underestimate. Let me think what else. Okay, and then the free response. I'm going to post all the solutions to these, but I cannot stress enough that if you have not done this in its entirety, like, I don't know what you're waiting for. It's time, people, okay? You need to be checking your answers. And just because I did it one way doesn't mean it's the only way to do it, but obviously the answer should be the same, okay?